Okay, I gave this talk at Develop this week, but I wanted to share a more public version, go a bit slower, and yeah, just put it up on here. So there. I'm also going to be putting a blog post that companions this because some people prefer to read rather than watch. Okay, so let's talk about shipping Godot to VR and porting to PSVR2. There's nothing that's NDA'd about PlayStation in this talk, so sorry about that. There are more juicy details if you're a PlayStation partner, where I talk about that stuff behind the scenes. And while this was originally meant to be a post-mortem, a bunch of stuff's happened, which means it's a partial post-mortem. Okay, so let's go through it. Who am I? Well, I'm Claire, and I've been doing this since the PS2 days. I contribute to Godot mostly on the OpenXR side, increasingly some render stuff here and there. I've published a whole wide range of games that I've been doing VR since 2013. I joined Sony to work on PSVR1, networking stuff, significant contributions to metaverse stuff, VR chat, hand gestures and all that stuff. That was me and my team at Sony came up with that. Yeah, anyway, doing a lot of stuff. Most recently shipped Dreams and Adobe Modeler, and now working on Augmental Puzzles. Okay, so up front, some of this talk is going to come across a bit negative, and I want to say it's not meant to be at all. Godot works for many, many teams, and if you're making a 2D game, it's kind of a no-brainer in many ways. And for most simpler 3D games, it's very, very reliable. If you're doing something that has an open world or a streaming component, or you're using heavy amounts of character animation, or you're going for a very realistic art style, then Unreal's probably a better situation for you. Likewise, if you're going for VR, a lot of out-the-gate devs, especially for standalone VR, might prefer Unity just because the render is a bit more capable. There is an asset store, but at the moment it's only free. That will be changing in the future, but of course that means that the ecosystem isn't as well serviced as other ecosystems. And console porting, there's a lot of studios that provide the service, but we've been doing a community port there, but in some ways it's less mature. Okay, so first question is, can Godot ship commercial VR games? Yes. We, however, had to pay about 80 grand in early adopter tax. It doesn't mean that every studio that's starting a VR game in Godot needs to pay this amount of money, but this is just pure engine work that we've had to do that if we were shipping on, say, Unity, we probably wouldn't have had to do. If you were starting now, I don't think it would be that high. I do think there would be a tax, though, just because there will be some stuff you need to do. This does not include the PlayStation and the PSVR2 work, but that's worth there, and we're in early access, so yay, that works. It wasn't our first game that we worked in VR. The first game was actually called Dean. It was an archaeological game. It's blocked by some missing render features. I've talked about this before. I didn't want to write an engine, I wanted to make a game, so I was like, okay, let's shelve this idea. This other idea called Rune Magic, which I gameplay reasons stopped, and then a game based on my wife's first trilogy of books. We ran into some physics trouble, early jolt stuff, and we cancelled it when our funding was cut, because this was why I left Adobe, and then to get back into games. And then well, anyone in the VR industry can tell you what sort of September 2024 looked like. Okay, so while I was at Adobe, I worked with Logitech and Apple and many others, but Logitech, I worked with them on this pen. I got support into Godot, which was relatively painless, and I made this little drawing demo. And when I made it, and I was kind of, what are we going to do next? I was like, well, I really want to play Sudoku in VR. It doesn't exist. Holy shit, we can make that pretty quickly. Let's get that out the door. So this is what I always say to people when they ask me about Godot. The speed of getting things up and running in Godot really is its strength. It's a joy to work with. We had the core game of Sudoku up and playable in about 2 days, and then we had the full menu flow out in a week, basically all the components of the game. So yeah, obviously things were still a bit scratch graphics and everything, but one of the nice things is like in Godot we were able to use the composition layers. We no longer use them because we go for a different art style, but that means you get really high quality 2D layers quite cheaply, and it worked really well initially for us, and we probably could have shipped with it, to be honest. But yeah, so up and running really fast. However, the game grew in scope, and well, I'll let this play, but for reasons I'll talk about in a bit, we decided to expand the game to be a much bigger thing, not just to be Stuku, but to be a lot of other things. And recently we finally were able to show some of our ambition there, because we launched nonograms. I love nonograms. You might know them as Picross. Picross is just Nintendo's trademarked name for nonograms. So that was really awesome to get out. And yeah, while our initial ambition was a quick sort of 3 month out the door, we fell in love with it, honestly. And yeah, the Logitech pen is finally shipping in production. And yeah, we announced that it's coming to PSVR2. Okay, so I've given other talks about this at Develop North. I talked about Godot from a professional perspective recently at GodotCon, and that's live on YouTube. You can watch it. It's a longer talk specifically about most of this stuff. And then if you're a PlayStation partner, I'm sharing more details about this in spaces where I'm allowed to. And another thing I don't want to talk too much about, because I've briefly covered it, is the monkey paw effect, in that we had a lot of personal issues delay the game. Short version is a lot of people in my life were sick. Some got cancer. Recently my cat passed. A lot of bad stuff happened, and we always joke about it now, because like when my friend joined the company, I think it was like within a month his wife was in hospital. So we had some bad luck there, but I shan't be dwelling on that too much. Okay, let's go into why this talk exists. This is really important for me. When I came into the industry, it was very common that programmers would skill up through basically having to fix the in-house engine or adapt an engine you were licensing from someone else to your game. And when new console cycles happened, as you sort of matured in your career, you would inevitably be asked to sort of port the engine across to new hardware, or support some bespoke vendor, or something like that. And developers would learn, and they would go down the path. Likewise, console developers, and when I worked at PlayStation, we were working on consoles, would often try to do new things, and new things usually appear in consoles first. But to do new things requires that people support and work with them. And one of the things that really sucked was in this last decade, as we sort of developed the standards and a lot of the APIs and the software around VR, pretty much everyone was using Unity Unreal. We were at the peak of the sort of engine duopoly. And it means that not a lot of people engaged in the VR standards, and the VR standards didn't get good, because I always say to people, the way to know if someone is using a thing is, are they complaining about it? Because if a programmer is using a programming language, if they're using a game engine, if they're using a console, they're bitching about it because they're talking about all the problems they're having. And that informed knowledge allows us to improve things. And VR's growth got heavily stunted by this. I would also argue there was a lot of innovation in the last console cycle that people don't realize, because basically Unity and Unreal didn't really engage much in the console's advantages. They did some shiny new graphics and such, but there was a lot of work we did in the console world that should have made games better and different, that didn't emerge. And like, as I say, in VR, there's so many things that VR headsets can do that you don't see games do, because maybe the Unity or the Unreal plugin doesn't support what they want to do. So innovation requires that we play with things, basically, is all I'm saying. And that's one of the main reasons I advocate for Godot, and also why this talk is out there. Okay, so let's talk about rebuilding Godot's core for commercial VR. Okay, so this is probably the slide that's going to get the most critique. It's not meant to be conclusive, but I had to very briefly tell people things. And again, I'm going to speak very much from the perspective of assuming you're a game dev who shipped on console and understands these things and maybe aren't as familiar with Godot. Godot at its heart is a 90s style object-oriented engine, right? It's been updated in places, but that is its skeleton. It achieves most of its scripting layers and extensions and a lot of the stuff through a variant union type, which basically just wraps up some common data structures. There is an object ID database that's kind of at the core of managing a lot of this as well. That's very mutex heavy, in-text locking. It's very awkward for threading. There is an authoritative scene graph, which is also parent relative transforms, and these transforms are also fat because they support non-uniform scale, which causes a whole bunch of problems with physics and graphics optimizations. And yeah, there's a lot of weight that comes with that scene graph that you wouldn't see in other engines. Also, the renderer is not bindless and it's not threaded. There is a threaded version, but it's still marked as experimental. We try to use it. We come across a lot of problems. It's still not recommended to be used. But this whole the whole structure really creaks under that. The memory model is probably one of the biggest issues. It's very POSIX heavy. It doesn't make a good use of memory mapping and such. There is a VFS with the package system, but it's not uniformly implemented. Like in Android land, it's still sparse file systems in the APK. There's a lot of internal caching and buffering and mem copy stuff throughout the engine. Not much use of like modern mapping structures. Yeah, there's a lot of I/O and energy like I/O data inefficiencies in the thing because it's largely built by devs who weren't shipping on console. The nice part about Godot, and I say this, Godot is probably the biggest issue. As I say, it was mostly devved by people outside of the industry, and you know, there were some egos involved there as well. But and it is a failed commercial engine that the only reason it got good was because it got a grant, and then a lot of open source devs came in and a lot of people worked, and you know, Godot 2 happened, Godot 3 happens, Godot 4 happens, and really in the Godot 4 cycle we see a lot more high level engagement in the engine, and the engine has been massively improved across the board. But obviously there's some core data structure stuff that is very hard to do updates on when you're in the middle of the cycle without breaking a lot of things. But the good news, it's very modular, and I always say to people, a game engine is like 120 things. Turns out the parts that annoy me or the parts that annoy you are probably going to be different. Maybe we have some overlap, but where you want to add your technical value to the game is going to be different for everyone, right? And you can choose just to fix up the parts that you need to fix up. You don't have to build an entire game engine. And at a baseline, it's good enough in most places. And then you can just sort of improve it where you need to improve it. And because it's designed like this, like a stock car, it's not meant to be perfect. You know, while it's very hard to pop the hood on Unity and Unreal, and I know if you've got a source license to Unity, you can do that with Unity, but it's not designed for it. Likewise, Unreal, you know, if you're a serious title in Unreal, a AAA title, you are shipping on a custom version of it in Unreal, almost certainly. But again, it's a lot harder to work with. Okay, so let's talk about two very quick stories. I've covered them before, but just to give you an idea, if you want more details, they're in my previous talks and on my website. So we did the Sudoku thing with the goal of shipping in 3 months or so, and the idea was to be very simple. And we had a goal of a friends and family build, which we were on target to hit, even though some personal life stuff was happening. And I had these horrible frame rate spikes. And I went down the rabbit hole. Eventually I found out RenderDoc was telling me, wait, because my frame rate was fine and my menus were simplistic. Like, there's no reason I should have been having render performance. but I was getting these material creation storms which were causing these spikes. I tracked it down to Label 3D because it created a unique material per glyph, and it relied on layers of caching to basically solve the problem away. But as we know, sort of high-level bad algorithmic things always come to bite you, and the MSDF texture would grow mid-frame, and there would be a lot of material thrashing that would go on there. And again, because it wasn't bindless, it was a horrible VR spike, and we would have failed submission, but also the game just felt really shitty. So rather than doing the friends and family, we tried to fix it. Now, this is really cool because this just happened this week. Back in the day when I've talked about this, I talk about my fast text fix, which basically writing a version of Label 3D that uses a shared resource to avoid this material creation problem, to share resources. And I did some general optimization to Label 3D, and we pre-cook the glyphs, and we do a single draw call per node. We don't have mesh surface per letter, right? But I've always said I want to move to like Slug style dynamic GPU fonts where we're actually encoding curves and you get like infinite resolution. I can tell you as of this week, because this year Slug put their patent into public domain. Now, to be clear, most of GPU fonts were already perfectly fine, but they had a software patent on a band compression stuff, which was critical for making it work in VR because it just speeds up the thing significantly. And while I was at Develop, in between getting ready for this talk and seeing friends, I finished it. And now we have wonderful non-MSDF, but rather GPU curve-based fonts in our fast text module. So that's very cool. I should also mention as a side note, there's another great VR game that's in development in Godot, Penguin Festival. And when I spoke to Z about this, his solution was, I just use text mesh. That would have worked out of the gate. And I tell people now, yeah, do that. It's not efficient. It's not as good, but it works. And, that's great. This is what I'm saying of like what bugs you, what doesn't bug you. But hey, it bugged me. And either way, we would have had to come up with a solution. And our solution now supports infinite resolution SVGs and fonts. Monochrome at the moment, I haven't done multicolor, mostly because I don't need a multicolor and I want to stay performant, but it would be fairly trivial to support full multicolor emojis and everything. And as I say, complex SVG rendering. Okay, War Story 2, compliance and front ends. Godot has a real problem in that if you want to ship on Steam, Godot Steam's great. And there's additionally plugins for Meta and Epic and Pico and everything. But because Godot, at its core, is an MIT license engine, and the Foundation wants to avoid any licensing issues, anything that could require a license or was problematic that way doesn't go into the core engine. Likewise, if something could have a lot of different ways to solve it, like terrain is a good example, then that doesn't go into the core engine because there's so many ways to do terrain. Let's rather keep that out as custom modules or extensions or whatever. So the problem with this is Godot at its core doesn't have basic API structures for things like users, leaderboards, transactional save data management. The save data management is still POSIX based, which is really horrible and we know we should never do. But hey, that's there. So it doesn't have transactional save APIs. It doesn't have a lot of this core structure that if you were using Unity or Unreal, you would sort of just take for granted and you could extend out. So what this means is every time someone makes one of these, they make it specifically for that platform. It has different APIs. It has a different interface, which means you get a whole bunch of things. And as someone who has been through console submission a bunch of times, we all know how complicated the TRCs can get and the compliance can get around user management and around state and session management, and the idea of having a per platform implementation of that, which could have per platform bugs in your game logic, is just kind of a mess. And I'd love to see like a generic MIT safe version of an API that these other things could hook into and encode, so game devs don't have to redo it every time. The other problem is a lot of these plugins are maintained in a community basis. They're not necessarily fully GDPR compliant. As a game studio, we have to sign our data user control agreements, and we have to be able to actually verify what's happening to user data, which means we'd have to validate all the code that's in these libraries that we pull in, and you have to be compliant. The legal fees and fines here are not based on revenue always. They can go extremely high, and in some of these cases, especially around child safety laws and other things, you can personally be liable, not just the company. So you've really got to dot your I's and cross your T's on this stuff. So we were like, okay, we're going to build a single, we called it, originally I think it was Butler for user management, or backend unified middleware. We've called it a bunch of things. It's a pun for bum, because it's dealing with the platform shit. And so this is one common interface for all our platforms. And then inside the module, we do per platform implementations that we can verify, and we can run through unit testing and everything. And it means the game only has one surface that it needs to implement against. It does things like offline modes for trade shows with increased analytics. It does things like multi-save slots, cloud merge with the transactional saves. And it has an auth state machine I know is compliant. So that was a big chunk of effort that we've done. And there was a lot of other small little things that we've had to do across the engine, some not so small, but those are sort of two examples to give to you. You might have heard me mention extensions, modules, add-ons. They're not 100% the same. They try to keep the extensions and the modules as similar as they can, so in theory you could move the code between the two. It's not really there. Android extensions can be a real pain. Fought us for weeks originally because, and this is actually probably one of the biggest gripes, is fuck SCONS. Fuck SCONS, really. I hate build systems generally, and we all hate build systems, and I'm sure SCONS is lovely compared to some other build systems, but no one in game dev uses it. It's just fucking Godot. And what this means is that none of the tooling and the solutions we as an industry have built really work for it. If you're using something like Incredibuild, or if you're using some other systems I can't talk about, then they will intercept the compiler commands, and so they'll work natively with SCONS. But even when they do that, it'll be slow as hell because of how SCONS constructs stuff, and it's single-threaded, and it's really bad because basically most studios, so people who aren't game devs, right? And I think this is where the problem comes with why SCONS and why the decisions are made. Because if you're working on like a normal open source project that's not game dev or whatever, you put all of your weight on your CI system, which is like GitHub or GitLab or whatever it is, and your CI system runs builds in the background, and you don't really care, right? In game studios, even relatively small game studios, everyone has a beefy PC, because you have to have a beefy PC, because you're a game dev, and games need more processing power at the time of developing them than they do at the time of running them. So your game dev PC is usually your recommended spec or higher, and if you're working in a game studio and you're paying salaries to people, if someone's salary is, 50k a year, 80k a year, whatever it is, 6 figures, if you're dealing with your programmers on the high end, then getting them a 10 grand PC with a Threadripper is pretty reasonable, right? And then you've got all these PCs lying around in the studio. Most of the time the CPU time's not used, so it's pretty standard, even in very small studios, to have a CD, a compiling distribution system that is built on your LAN, these days using something like Tailscale to distribute it for remote studios, so that it doesn't slow down people's PCs when they're using it. It's very respectful of idle. If you're looking for an open source solution, I recommend fast build. And that means that when people need to compile things because they're working on the engine, it compiles very fast, But anyway, SCONS is non-standard. I'm not saying I like CMake, but basically everything in the games industry is either CMake or Visual Studio or something built on top of those two solutions. Loads of people use Ninja and all these other systems, but it's basically one of these two things, and then people build on top of it. And as I say, this is not a complaint about SCONS as a software stack. It's about the fact that SCONS isn't standard. That's the problem. So we've had to do a lot of work around that. We had a lot of issues around Android headsets and JNI bridge, especially with Epic Online Services, because there's some requirements and injection stuff there that goes on. We had issues with external lib libraries and linking and build chains and just getting all this stuff sorted. It cost us a lot of time, effort, and money, and delayed, in cases, months of work. And now, recently, as we're porting to more headsets, we've had to move the extension back into a module because not everything was playing nicely with some of our JNI stuff, and we're still tracking down some issues related to that. So this is an ongoing point of pain daily for us. Okay, let's get on to the PlayStation stuff. Right, so why a community port? There's lots of porting companies that were doing porting to console for Godot, even before W4 did their port. However, when W4 came in, and again, this is all happening in September 2024, 2024, when I was, we were in the middle of a lot of stuff, so I was maybe a little angry. The fact that the W4 console port was announced on the official blog, the fact that certain egos were involved and bad comms, for a very long time, this continued, in a way that the average Godot user or person who was just glancing at Godot, or even people who were reading the blog post, got the impression that the W4 console port was the official port. Now, Godot is, ever since the 4.0 cycle, so this is recent, run by a foundation which has a very similar structure. It's inspired by Blender, and I think the foundation does wonderful work and great work. And W4 is a private company that unfortunately has some name recognition because of certain people in the company, and as I say, like, there's an over ascription to personality. It happens all the time, right? People are like, oh, but so-and-so is so important. It's like, have you seen all the programmers cleaning the mess up behind them? Have you seen all the other people working? So yeah, anyway, it was a problem. And I felt it was very much not in the spirit of Godot. And it didn't solve a lot of the problems I was facing and why I was investing all this money in Godot in the first place and not using, say, Unity, right? Because if I wanted to use Unity or Unreal, they're better engines from a technical point of view. I was making these decisions for other reasons. And so it didn't align. And I was like, I threw down the gauntlet a bit. And I was like, hey, there's a community Switch port. Why isn't there a community PlayStation port? And this is also coming from the fact that I worked at PlayStation, I worked on the PS5, and I was quite frustrated with the poor support I was seeing for platform features. So I was like, let's do it. Let's make a community-based thing, and that's where that came from. So where is it now? So you could start, there's 2D games that are currently being ported. The samples, the 2D samples, largely run. 3D lighting work is currently in progress, and there's platform work to done, and nothing's gone through submission. But if you're a PlayStation dev, you can go onto the PlayStation forums, and you can ask for access to the Discord. You'll get access to the Discord, you'll get access to the repo. And that's for the 4.5 community port. There is an addition, as of a few months ago, since the GodotCon talk I gave, a 4.7 talk that's 4.7 port that's 100% VR focused, and is actually a complete rewrite of the render server. So that's the thing. I'm still actively contributing to the 4.5 port, but it's just where the render stuff differs. Okay, so let's talk about this port. So I was very focused on the studio and trying to get things off the ground when George reached out to me. And George is the GD script lead maintainer, and he basically said, hey, I want to do this. I have a porting company. Let's collaborate. And at the same time, André, who also has a porting company, reached out to me and was like, let's collaborate. And we organized and we got together. and we were like, oh, okay, let's do this together, which was great because, as I said, I hate build systems, and George has a very deep knowledge of Godot that I don't have, especially around SCONS and things like that. So he built out the base of the 4.5's like plumbing for build systems. He built a lot of the initial modifications to the SCONS files, and so we could export to console and do those basic plumbing things, which I cannot give him enough credit for. It sped us up immensely because I'm terrible at that stuff, and he did a very good job. However, the monkey paw effect came in, and after not too long, he had personal life issues, and he's had to largely step away from the port work. But I still want to acknowledge his contribution, as it was massive. The 4.5 port is now led by André. He got us the first hard-coded triangle on the PS5 hardware, and he's doing a very good job of doing that, and he's actively porting some games using the 4.5 work, so it's moving forward quite nicely. I did a lot of the memory model stuff, as I said, POSIX, the file system stuff. Without talking PlayStation NDA, I can't give you a lot of juicy details, but it had a lot of issues. And then figuring out save data, and then as I'm doing this, because obviously memory allocation and GPU work's really closely tied to what André was doing, I was like, well, let me just show you what I mean. And then I got really stuck into it, and I did a large chunk of render work, and the biggest thing is the shader pipeline, which was probably the largest pain point, and I'm still not happy with the solution, hence stuff. Okay, let's talk about the big first fight that I had to tackle. So Godot's file model's rooted in POSIX. Now POSIX is old. It was old at the turn of the millennium. We have much better low-level file management ways of describing things like native mapping and such. It funnels all the save data through the user mount, which again is a file access style system. It's not transactional save, so it wouldn't pass TLC. I should take this moment to acknowledge, okay, so that image, the bottom right, is from a Mac. However, anything that's not a bloody desktop PC looks like the thing on the right, right? Your phone looks like that. Your VR headsets look like that. Your games consoles look like that. Your Macs look like that. Hell, even some Windows PCs look like that. Especially if it's a laptop, or the Steam machine looks like that. The Steam Deck looks like that. SoC unified memory architectures are the norm, and even if you're not dealing with that, if you're still thinking like 90s brained, or even like Xbox 360 brained of 10 plus years old, the sequential read times compared to modern systems is incomparable. And if you're still coding and you're doing your core data structures in a way that's very cache heavy, you're not making good use of hardware at all. And as I say, POSIX file systems were a bad idea even in the 360 PS3 era. And the virtual file system that PCK gives you is not optimal and could be a lot better. And it's not consistently mapped across platforms, which means how it performs on different platforms and hardware varies quite a lot. And it's riddled with local cache problems. The amount of times, the amount of reads and the amount of copies a texture, for example, takes to go from cold storage into GPU it's a lot. And it's like across the board, resource loading, all kinds of stuff. And I think the biggest problem was Godot exposes this file access API as a primary API to users, and so a lot of game devs in their GE script and in their actual core game logic make heavy use of it. So mapping that to how anything that's not a PC works isn't great, and it also encourages users to make bad file management systems, like bad loading systems, and it slows everything down. It's really shitty. So we tried to do our best job there, leaning heavily on the resource system, but honestly, in the end, we kind of just there's stuff I want to talk about here, but it's platform specific. we have a thing in there. It works. It could be better. It could be a lot better. The next big fight was the shader pipeline. So GD shaders largely just run. GD shaders are basically GLSL. Wait, HLSL? I forget which one. Pretty sure the slide's right. GLSL. I might be wrong there now. My brain's thinking through it. I can't remember. Anyway, pretty sure it's GLSL. Fuck my brain. Anyway, they just take the snippets, like, you know, vertex, fragment, or light, and those are basically just copied and pasted with templates into these very large files, and macros are turned on and off for variants, and these very large files are then passed to SPIR-V compiler. It's actually a little bit different now because Direct 3D uses Mesa translation, I believe. I have to remind myself. But this goes through and then goes into SPIR-V cross. So for most platforms, SPIR-V can then spit out a native format, right? So like it can spit out what the GPU needs on your particular platform. Now, one of the problems with this is, like, on Metal, it goes through a translation layer. It uses a SPIR-V cross and it spits out, I think it uses Mortem stuff. I'd have to double check. It's been a while since I looked at it. But anyway, the point is, we take your little snippets, we paste them into a big file. That file has a bunch of variants that are made of it, like bits of things are turned on and off with pre-compilation, and then that's fed as a standard, I believe it was GLSL file, into SPIR-V, and then SPIR-V is seen as a unified cross-platform format that can go across these different things. The issue with this is that, again, it's this the compiler will optimize it away mindset, which is not great because undefined behavior is a thing. I've got a friend who works on the PlayStation shader compiler. Like, I've had conversations with other graphics programmers about this because, you know, I'm not the best graphics programmer, but this causes issues throughout. Now, between when I was doing this work and today, so between 4.5 and 4.7, there has been some work to trim the file that's sent to SPIR-V. Still pretty terrible, but there's been some work to improve that. But before that work was there, I had to do a lot of sort of custom work in the SPIR-V cross compiler. I had to have a custom branch of it to make PlayStation shader language files. And anyone who knows AMD GPU architecture, without breaking any NDAs or whatever, but like if you know it from PCs or if you know it from Macs or a bunch of places, you know that the shader resource tables and the registers are much smaller on those systems than, say, in a NVIDIA GPU or whatever, because it's more optimal to do it that way, right? And with the SPIR-V cross solution, you start hitting all kinds of horrible hard limits. I don't mean just performance issues, I mean will not compile issues. And because we have to maintain these binded layout set structures throughout, it gets really messy. And the worst part of this is once you've done all of this, the file you're writing, the GD shader file, and the file you're debugging on console have gone through so many steps, it actually makes that iteration process really shitty. So it's not a nice experience. The pipe's very long, and the amount of transformations the thing goes through the pipe is not great. So I really didn't like that. Spent a lot of time on it. As I said, we did a SPIR-V cross backend that emitted native shader language. We had these massive reflection tables and huge scripts that were going through the 200 to 300 shader variants. I can't remember the exact number, but I had a whole system that was churning through it, and I'd basically go, oh, these shaders aren't compiling, let me figure out why, can I put special exceptions in for it, okay, boom, boom, boom. Because the whole goal was that if you're using the 4.5 community port, you don't need to redo your shaders, right? We were trying to make it as turnkey as possible. We got there. As I said, 2D samples are playable. There's still a lot of work to be done. Programmers welcome to join that, and please help us out. I should also point, while I talk about this at all, originally Clay put together a shader template proposal. This is what led to compositor effects. Compositor effects are not very optimal in how they're done, but they're a way to inject some custom render stuff, and it sort of took off some pressure in the mid 4x cycle. There is a more modern proposal for shader templates that Bastian, the head of the XR team, has put together. This is the idea that we could have sort of custom template files. And I really like this idea because it means you can do optimizations per platform. You can have these more stripped down shaders that are more specific to your needs. But what we would have probably done with this, and we talked about it, was we would have probably made shader templates that basically ingested. We would have basically replaced the GD shader pipeline with our own in some ways, or at least we'd have GD shader templates that for those 200 to 300 files would cleanly move stuff across, right? Not the best solution, but it would have been a good solution. But regardless of PlayStation, I think that the template system is pretty good. I'm trying to remember what that other PR was about. I can't remember what that other PR was about. But there was a lot of movement in this area. So I'm hopeful this will get fixed, by the way. So anyway, I hit a breaking point. I'm porting all this down to 4.5. I'm hitting all these problems. I'm hitting these mutexes. I'm hitting this non-bindless stuff, which is not the norm, right? Almost every renderer out there is bindless now. And I went to Godot, I gave my talk, and I spoke to, there was a great NVIDIA talk there, and speaking there with, his name's later in the slide, I've forgotten it right now. I realized I came to the conclusion that I wasn't building a good PS5 engine. I was porting bad technical decisions, outdated technical decisions to modern silicon, and it didn't feel good. And at the same time, some business conversations happened, and I was like, I don't like this. So I came back and I was like, fuck it, why not both? So for any of those who know the architecture here, I'm going to just move myself for a sec. What happens with Godot is we have got forward render clustered, forward mobile. Forward mobile is what we recommend for VR, and we've got a compatibility. These are actually backed by two compositors. One is the render device compositor, and the other is the GLES compositor. The GLES compositor plugs into OpenGL, Glaze, and Angle for Mac and some cross-compatibility stuff. And this is what you use for web and things like that. And it is a very old-fashioned pipe. Very, very old-fashioned pipe. But it's there, it works, it's a good baseline. The render device compositor, the way most of these platforms are supported, like Vulkan, Direct3D, Metal, is you actually have the device layer, and then for the 4.5 we were like, let's do a PlayStation device, based largely on the Direct3D 12 device, because that's a better base than Vulkan. Now, the problem with this is anyone who knows graphics programming knows that if you're supporting all of those backends, you're basically making the worst version of all of those backends, because you've got to make compromises, right? And as I say, I understand how it's happened, but because forward clustered and forward mobile share the same thing, there's a lot of decisions there that could be split out, that aren't split out cleanly, because it's easier to modify a thing in place, it's easier to push the PRs through. There's a lot of sort of code maintenance and community pressure stuff that is there. Should also mention both those compositors have a whole range of little sub things they mention for material storage and all those bits. So there's a lot here. So I was like, fuck it, let's do both. Let's just write an entirely new render server, and then we don't have to deal with a lot of those decision pipes, right? So a third option, if you will, from Composite RD or Rasterizer GLS. Now it's our plan in the future to make a version of this that's backed by Vulkan or Direct3D or Metal or something more modern, maybe a web GPU, to make it more open source, but it's a pure new render server. So that was the 4.7 decision. Let's go here. There we go. Okay, cool. So the architecture of the new renderer. It's a pure bindless renderer that attempts to be as lock-free as possible. It uses producer-consumer ring buffers for tight command streams with no ObjectDB mutex tax, because I've managed to eliminate a lot of that. I've done a lot of mutex optimization stuff. It has explicit core affinities, which is really critical for cache thrashing and a bunch of other stuff, because of how in a lot of these systems CPU cores are paired up and stuff. So we're very explicitly like physics is running here, game loops running here, renderer running here, these are the subjobs associated with this, blah blah blah. So we've mapped it out specifically to hardware, rather than having the pipeline determined through shaders and some other render state stuff. What we've done is we've written our own version of the sort of shader template concept, but we've gone harder on it, where every material drives its own execution. So what this lets us do is it basically, we still can just cluster stuff by materials because we know that they're going to need similar things, but it means that a material could be a volumetric shader, it could be something like an intersection shader for ray tracing, but it also means that for example, for canvas rendering, we actually do this really optimized thing where we're squirting tiny amounts of information through that cater for the vast majority of canvas cases, but not all canvas cases. Likewise, we've also just gone, we don't support non-uniform by default. Everything is just uniform scale, and then if you need non-uniform scale, we can interject a deformation step, because it's the special case, not the common case, which means we can do a whole bunch of speed ups to the GPU pipe. The other decision is because of the material driven pipelines, the idea is you have platform native shaders, right? So on PlayStation, you're just writing PlayStation shaders. On Apple, you're writing Metal shaders. And this sounds like a lot of work, but the reality is copying a folder of shaders and then going through and making a few minor changes here and there is really quick and easy. It's not a lot of work. And ultimately, you probably do want platform-specific shaders because platform hardware is different, right? And so there's different compromises you want to trade off on there. So this whole idea of a unified shading language, it's lovely, not super practical in performance terms. So that's what we did. And it was heavily inspired by Seb. He's giving a talk at SIGGRAPH this week, and his post about no graphics APIs, and talking about how we move to a post-Vulkan bloat world. Very, very good blog post. I highly recommend it. And there were thankfully some people who had done some implementations, like the DAXA renderer in Vulkan, that have started to play around with these ideas. So I could look at some other code references and go, oh, okay, that's how they've interpreted it. And then like look at PlayStation hardware and go, this is what's best for PlayStation, not worry about any other platform, and in the future I can think about that. Right, okay, so let's share some fun images here. So these are just progress images from the PlayStation port. It's been really fun to have these to sort of share. So what you'll see is us working on the canvas renderer, getting to texturing in. Each of these is like a little test, getting a whole bunch of like shader pipeline stuff in. So that first triangle there's the first thing that goes through shaders. And then we're doing a lot of tests like writing with compute shaders, supporting all the different kinds of pipelines, mesh shaders and all those things, supporting importing and baking shaders through the editor, things like do we support instancing correctly where it's per object and we can do this shader reflection stuff that we need to do, because we have to annotate the platform native shaders in some cases, because the shader reflection stuff's very good, works really well. Most of the time we don't have to do anything, but sometimes we want to sort of do a bit of annotation to the shader to expose it. We got the VR running, so that's great. Been working on lighting in the last week, so shadowing's not yet in. I don't know if we'll do shadowing explicitly or how we'll do it, because we're focusing very much on VR and dynamic shadows aren't as big a thing. But one of the nice things is, because we were targeting 120 FPS for our shadowing system, we can actually decouple the shadowing, real-time shadowing, from the frame rate. And there's a bunch of interesting SIGGRAPH papers and things we can do where we're like, because we're building for VR and it's a VR first renderer, what if our shadowing technique can slowly smear over a couple of frames, and then we can do some cool tricks. We can do some very cool tricks there. So we've been looking into that. That's active work at the moment. Cool times. Okay. So if you're a game dev, you might have remembered the Fire engine. So when we were moving from the PS2 to the PS3 era, or the 360 era, that was when we were moving from fixed function to shader pipelines. And it was different, it was new, and I maintain that the PS3 architecture was definitely in the right direction, maybe a bit too early, but it's where we're heading now, with these general purpose compute units, and then specialized little sidecar hardware like DSPs or neural net stuff. So Sony was like, let's make an engine, we'll call it the Fire engine, and it's MIT licensed and any dev can use it, and here's how we think you build a game engine for PS3. The sad part, it wasn't built for a specific game, and so while a lot of devs looked at it and took code from it and used it, because again it was MIT licensed, a lot of these platforms do a lot of MIT licensed code. The problem was no one was using it, and so the team never got enough love. Now, it's also true that platform holders constantly lend engineering time to proprietary engines, right? So like Unreal, Unity, or big games like Call of Duty and GTAs and stuff. Or in my case, when I was there, I was often helping indies out with smaller stuff in little bits, right? So platform holders invest in this. And like in Godot, we've had engagement from Apple and Microsoft and, like the Cronus group. Godot's OpenXR implementation is the implementation of reference for OpenXR. As I say, that's how I got involved in Godot. I totally forgot to tell that story, but whatever. So the hope is that if we have a community port out there, we can engage people at PlayStation, my old friends, and go, hey, here's a thing, could it be better? And if you're working at a place, Godot's a great place to go, well, I could make this very simple C program that shows my rendering technique or this new platform library I want to show off, or I could implement it in Godot and show it in an actual engine as a proof of concept. And not only does that mean I'm putting it into something that's more realistic, something that people use, something that people want, but it also means that it's MIT licensed and immediately engageable for people. So if there's other people writing custom engines, their custom engines are more likely, it's easier to pull stuff from Godot than it is to pull stuff from a sample or from Unreal or whatever. So that's it. And this is already happening, right? This is already happening. So as I said, NVIDIA, ray tracing, Leroy gave this great talk at GodotCon. He could have built that, and the traditional way to do what he did would have been to make a standard sort of C test sample program to show off the new NVIDIA render stuff that he was doing. But instead he was like, fuck it, I'll build it in Godot. And now a lot of Godot people have been helping him, been engaging, he's been getting good feedback. It's a much more valuable thing for NVIDIA than if NVIDIA had done it as a standalone project. NVIDIA's got a lot of value out of it, and the Godot community's got a lot of value out of it because it started a lot of good conversations about what ray tracing looks like in Godot. So it's hugely valuable for both Godot's community and for NVIDIA. Likewise, Apple Vision Pro, anyone who doesn't realize Apple's still very much in the VR game. WWDC was filled with VR announcements. And, you know, they've contributed time to improve Godot's metal renderer. So Godot works better on iPhones and Godot works better on headsets and everything. So that's great. Some of that's private engagement, some of it's not. But then the cool part is they did this announcement of this Godot reality kit. Now what this means is you can take your 2D Godot game, right, 2D, and it just works in Apple Vision Pro because they render it onto a quad. But you can also take a 3D game, not a VR game, a 3D game, and again, it just works, but it's rendered into a volume. You can also take your Godot VR game and you can bring it to the Vision Pro with their immersive stuff and still use Godot's metal renderer, right? But then even cooler, they've gone, well, if you want to go the whole way, we've got this reality kit thing where we fully replace Godot's renderer, very similar to what I'm doing for PlayStation, and you get the best possible renderer for Apple Vision Pro, and your Godot game just works out the box. And that's really fantastic. That's really, really cool. And it means that, you know, the Godot team doesn't necessarily have to maintain that renderer. Yeah, it does mean that Apple's going to make some specific calls and maybe there's some slight differences there. But this is the kind of engagement that you can do with community-based ports and work, which is why I think they're so, so valuable. So the takeaway for studios from our lessons, you don't adopt Godot because it's a turnkey solution. You adopt it because it's a seed for your technology stack, right? It'll get you going fast, and then the parts of it that you need to change will be different from the parts that everyone else has to change. Maybe you're working on a Lemons game, or maybe you're working on a tactics game, or a game that has a lot of digging or Minecraft stuff in it. The technical bits that you will want to optimize are going to be different to you, and those technical bits are also where you can build value in your studio, and you can go, well, no one else can build this because we spent a bunch of time investing in this code that's not Godot specific maybe, but it is part of our USP, or maybe it is Godot specific, you know, it's there. So in our case, for example, we've got a full puzzle solving AI thing that I've written up. That's a core part of our sort of studio value. But yeah, you own it. It's code. It's free and clear. You don't have to agree with everything that's happening in Godot main. You can just fork it. You can make those decisions. But the best part is, even if you end up replacing a large amount of Godot behind the scenes, the Godot interface, the Godot metaphors are going to be very, very similar. And one of the hardest problems traditionally in the industry, which with custom engines, is you hire a new person, and the time to spin up that new person is very hard. It's hard to bring in freelancers. It's hard to do all that. Godot gives you this common language to bring in, this common interface to bring people in with, and it allows you to spin up people a lot faster and get a lot of the competitive value, business value that Unreal and Unity saw, which is why we saw so many studios forced in some cases to move away from their custom engines, because their hiring costs were too high, or they couldn't easily work with codev studios or outsourcing or whatever, or it was pushing costs up, or there was technical risk. Godot minimizes, it doesn't take away, but it minimizes a lot of those from an entirely custom engine. So these are good reasons for a studio to invest. Okay, other things that are happening in the Godot world. The Foundation recently posted a vision for Godot engine, which is really critical, because the start of conversations around Godot 5.0 have begun, and Godot is a very big community, and the Foundation's doing a great job of shepherding it, and there's a vision statement which probably should have happened sooner, but I'm so glad it's finally there, and I think honestly it happened when it needed to happen. Outlines these core goals, and these let you know if Godot's ready for you and if Godot's future aligns with you. So for example, one of the things that's in here is runs on hardware people own. right? And so this is talking about Godot being able to work on, like, say, low-end Android hardware, right? Now that sounds like the engine doesn't align with my high-performance VR goals, but it isn't the case. All it means is that any work we do for high-performance VR, if we want it adopted by the wider community, or if we want to be in line with where the foundation is, has to be built in a way where it can be turned off or live nicely alongside solutions for low-end hardware. And it also means that any work that we do on this high-performance stuff is secondary to the work to make it accessible. And so it's an alignment of values, it's an alignment of investment, and it sort of helps us adjust our strategy and how we engage with Godot work, right? So it's important to read these, understand them not only in letter but in spirit, and think about how you can positively engage with them. Rather, don't see these as like gauntlets thrown down of like lines in the sand and things are drawn, because most of the work of Godot is communication, community management, and how to get all of these people aligned. The actual producing code is actually one of the smaller parts, even though ostensibly the product of Godot is a thing that you compile, right? Most of the work is actually soft work, if you will. Okay, so that's basically the talk I gave. I might have missed some bits. I didn't have all my notes in front of me. There's a Godot XR Jam in September. If you want to dip your toes into Godot and play around with VR, I'd highly recommend it. It runs a week. If you're a PlayStation developer, go on to DevNet. There's a thread there. You can request access to the Discord. Once you have access to the Discord, you can get access to the code repository. The 4.5 work is all available. We encourage you to contribute. We do need more people to work on it. There are active ports underway. The 4.7 render work I'm doing is currently not being shared. However, anything that is not the renderer, I am sharing to the 4.5 work, because there's still a lot to do there, right? If you're a render person, I would hope that you would engage in some of the shader template material, bind lists, the future of Godot conversations. We do need more experienced industry people who have time to engage. Also, based on recent things that people have said around Godot, I want to encourage you, if you're looking to contribute, reviewing is almost more valuable than writing code, especially if you can review from a informed position. That's really helpful, really, really helpful, because there's a lot of hard rendering discussions to be had, as you can see from the talk. I didn't cover the OpenXR extension matrix stuff. Oh yeah, our game, Augmental Puzzles. I'm terrible at promoting it. It's an early access, it's there. We're trying to make it better every day. We're currently in the process of porting to like 5 different platforms. And as I say, doing a lot of work to solve performance problems, which we have. So yeah, it's there. Please engage with it. Any support you do there does help support the PlayStation work that I'm doing. We don't have a mechanism to support the port directly because it's quite complicated. But there are a few studios who are now sort of digging in, and we could always use more, especially if you have experience in the space, because informed voices are very, very needed. And I hope that encourages you to check out Godot a bit more. I hope as you go back to your studio, it helps. And feel free to contact me online and ask questions. I'm on Blue Sky, I'm on LinkedIn, I'm on X occasionally, I'm on the Godot Rocket Chat stuff there, and I'm reachable. And I hope this is helpful for you guys. And as I say, I'll try make a blog post that accompanies this, so for those of you who prefer reading things, it's there.